and we can start talking about the important things for today. We are used to functions. We are used to functions which are of the kind y equals f of x. And they are called functions because for each of the values of x, you have only one possible value of y, which is called f of x. And for such functions, you have you have graphs of y as a function of x, which are functions that don't intersect. So something like this is the graph of a function y equals f of x. And you can see that if you draw a line up vertically at each of the values of x, you will cross that graph exactly one time at the value y, which is f of x. Now, what we are going to be talking about now will be curves. Curves which are allowed to self-intersect, which means for one value of t, you have one value of x and one value of y, but the same value of x can correspond to multiple values of y. So for a curve, you are allowed to have something like this. That would be a curve. You can define this as y equals f of x because if I draw a line here, I'm going to touch that graph twice. So I can have this as y equals f of x because if I take this value of x, I'm going to have two values of y. But then I can define this thing as a curve. How do I do that? That's where the topic of this course comes in, parametric curves. These curves are often defined as x equals x of t, y equals y of t. So both x and y are functions of another variable, which is called t. In most of our problems, that variable will be time. That's why it's denoted t. And then you will have a range for that value of t. So t from sum A to sum B. So we can have many different examples of this. You could have something like that. You can see that here you actually cross the same graph, right? Here you have two values for the x. There you have two values. On some, you can actually have more than two values for a given x. You could have something like that. I will still be a curve. It's possible to give a formula for that and study the properties. Okay. Let's say an example of this would be, let's say x of t equals cosine of t, y of t equals sine of t. Actually, this thing, if I do this, that will define for me a circle of radius 1 centered at the origin. How do I know that? For each of the values of x, for each of the values of t, you plug it in, you find x, you plug it in, you find y, and you put the corresponding point on the graph. For example, here, if I say t, x, and y, I give this table to find the values. Then when t is 0, I plug in t here, 0. That's cosine of 0. I get that x is 1. I plug it in, I get sine of 0, I get in 0. So I put on that graph the point of coordinates x equal 1, y equals 0. That's here. Then I can put t equals, let's say, pi over 4. These are the angles that we know. Cosine of t, cosine of pi over 4, that's root 2 over 2. Sine of t, that's sine of pi over 4, that's going to be root 2 over 2. And you put that point on the curve as well. That will be the point root 2 over 2 and root 2 over 2. And then you can have pi over 2. You plug it in, cosine, you get 0. Cosine pi over 2 is 0. Sine of pi over 2 is 1. So that point is here. And technically in this example, what you can see is that that t is the angle that you have here. And so if you continue doing this, plugging in the numbers, you will obtain all other points. You have this point, then you have another one halfway here, then you have another point, and then you have another point halfway here, and then you have another one at -1. And it's a circle that you get actually. So this here is the parametric equation of a circle of radius 1 centered at the origin. Okay. Now, in general, an equation of the kind x of t equals r cosine t, y of t equals sine of t gives you a circle of radius r centered at the origin, and x of t equals x0 plus r cosine t and y of t equals y0 plus r sine of t. That will be a circle of radius r centered at the point of coordinates x0, y0. So that's the parametric equation of a circle. Now, for a line, you have two cases here. If given A of coordinates XA, YA is a point of the line, and U equals U1, U2 is the direction of the line. And then we will find the equation of that line by writing that the vector AM is T times U, because saying that the vector U is the direction of that line means that any vector that is on that line is a multiple of the vector U. That is what makes U the direction of the line. And this is a vector notation which can be written component-wise as if M has coordinates x, y, which is what we are looking for. This can be written as x minus xa, y minus ya equals t times u1, u2, or x equals xa plus tu1, y equals ya plus tu2. This is how you find the parametric equation of a line knowing a point. This is the point, and this is the direction. What I mean when I point there, I'm pointing the set of the two coordinates, the set of the two coordinates. So the parametric equation of a line is obtained by adding to the coordinates of the known point t times the vector direction. You can put an example here. A with coordinates 1, 2, U equals 1, it's minus 1. Then x of t is equal xa, that's 1, u1, that's 1 times t, 1 plus t, and y of t equals 2 minus 1 times t, 2 minus t. So this and negative infinity less than or equal to t less than or equal to infinity. This is the equation of the line that goes through A in the direction U. And it's important to know that here t is from negative infinity to infinity. That's what makes it a line. And the second problem there is if you are given A with coordinates xa and ya, and B with coordinates xb and yb, That's the equation of the line through A and B. The line that goes through A and B, how do I find the equation? So this problem turns into the first one by making sure you define U as the vector AB. U being the direction of a line. If I take any 2 points on a given line and I join them, then I obtain a vector that is the direction of that line. That's what this says. So here, that AB, how do I find the components of a vector AB? I take the components of the vector B and I subtract from them the components of A. So that's going to be XB minus XA, YB minus YA. And then I pick any of the 2 points and I write down the equation as up here using that point and the direction that I just found. Am I making sense here?
Yes.
And so here, I'm going to say here, X is equal to XA plus T times XB minus XA. Y is YA plus T times YB minus YA. Negative infinity less than T less than infinity. Here, you didn't need to put the or equal, right? Example, equation of the line that goes through A with coordinates 3, 4, and B with coordinates -1, 2. And say answer. U equals AB equals XB minus XA minus 1 minus 3, 2 minus 4, and this is -4 minus 2. That's the direction. And so I say X equals XA, that is 3 plus minus 4T. Y equals YA, that's 4, and then minus 2T. Negative infinity less than T less than infinity. Is this clear?
Yes.
So that's it. That's how it goes. Now, on this same topic, you have something called a line segment. Equation of the line segment AB. So you have a line segment that goes from A to B. In that case, you have to restrict T from 0 to 1. That will be X equals XA plus T times XB minus XA. The same equations that we had up there. Y equals YB, YA plus T times YB minus YA. That same equation, but with the condition that 0 is less than T less than 1. And then you can see that when T is 0, you plug in 0 for T. This is 0, you get XA and you get XB. So when T equals 0, you get the point A. and it moves all the way to b when t is 1. When you plug in t equal 1 in this formula, you obtain xb and yb. And this is important to notice, to know the range of t for which you're defining the line segment, because the difference between the line and the line segment is only that range. For a line segment, you have a range that is limited, and for a line, the range is not limited. It goes from negative infinity to infinity. Any questions? Do we have any question? Okay. Now, in general, for any other curve, you might be asked, for any other curve, you might be asked to find the parametric equations or to exclude t from the parametric equation to obtain what we call the Cartesian equation, right? The Cartesian equation of the curve is often given as a function of x, y equals 0, and the parametric equations as x of t, y of t. One can be asked to derive one from another. All right. So sometimes you might have the Cartesian equations and you are asked to derive the parametric equations. In another time, you might have the parametric equations and they ask you to derive the Cartesian equations. Example. Let's see, x of t equals root t plus 2, y of t equals 2 root t, 0 less than t less than 16. And the question first is eliminate the parameter to obtain an equation in xy. So when the question is asked in this way, that means that they want you to give the Cartesian equation, because what is given is the parametric equations. So how do we answer this question? What you need to do when possible is to solve for t in one of the equations and plug into the other one. Otherwise, you need to use the properties of the two functions that are here and find a way to exclude that. There is really no general way of doing that. That will depend on your skills, what you know of calculus. On this specific example, I can solve here. I can find root t equals x minus 2 from the first equation. And I plug that into the second equation, I get y equals 2 root t, which is 2 times x minus 2. And this equation is y equals 2. This answer, this equation that we got here is also an equation of the line. Just this is the Cartesian. Now, given that t is from 0 to 16, so it's not a negative infinity to infinity, so it's going to be line segment. And now, why did I pick this example? To emphasize that depending on the parameter that you choose, the equation of a line might not be what I gave you here. It's a choice of parameter that gave this answer. For a different choice of parameter, for example, in this problem, this is what you get. X of t is root t plus 2. Y of t is 2 root t. It's also that same line segment which is given as this. All right. So general Cartesian equations. So one for a line, the Cartesian equation of a line is ax plus by plus c equals 0 in general. Circle, that is x minus a squared plus y minus b squared equals r squared, where r is the radius and AB is the center. Example, let's say x plus y minus 2 equals 0. That's a line. X minus 1 squared plus y minus 2 squared equals 4. That's a circle of radius 2, centered at 1, 2. Any questions? Do we have any questions? All right, if you guys have no questions, let me ask you to do this example. Exercise. We have x equals 2t plus 1 and y equals 8t cubed minus 3 less than or equal to t less than or equal to 3. And the question is A, obtain an equation in xy, and B, describe the curve and give the orientation. All right, I'm giving you 5 minutes to work on that. Anyone with something to share? Nicholas?
Yeah, I could share.
All right, go on. So what do we do for A?
So the first thing I did for A was I solved for x. So I set x equal to 2t plus 1, and then solved for, well, x minus 1 is equal to 2t.
And then?
And then I plugged it into the equation y equals 8t cubed, which meant that y was equal to x minus 1 cubed.
That's correct. So the equation is going to be y equals x minus 1 cubed. And how do you describe this curve?
I described it as a positive conic function, but I'm not sure if that's right.
How does it move when x goes from -3, when t goes from -3 to 3? You can technically actually just try to sketch that. You try to sketch? When t is -3, this is going to be x equal -5. And when t is 3, that's going to be x equal 2 times 3, 6 plus 1, 7. So the x is increasing. So it goes in the increasing direction of the axis, right? So it goes from left to right. That's about the orientation as it is asking. Okay, so it starts at the point when t is -3, we said that's -5. And then here, -3 cubed, 8 times 3 cubed. So let me just write 8 times 3 cubed, okay? With the negative sign, starts there and moves in the direction of positive values of x. That's enough to describe it, right? So it starts there and moves in that direction. And ultimately ends at the point where you have t equals 3 and you plug in there. You get 6 and 7, and then 8 times 3 cubed. That's the point where it ends, starts at this point in the positive direction of x. It's towards this point along that equation, y equals x minus 1 cubed. Any questions?
I have a question.
Yeah.
Where does the why is there no 8 in part A of the answer? Or like where did 8 go?
That's 2t cubed. 2 cubed is 8. Does that answer your question?
Yes, sir.
Because y is 8t cubed, and that 8 is 2 cubed. So that's 2t, everything cubed. That's why you have parentheses. All right, now another thing that we can have to do here is the following problem. Find the parametric equations that describe the circular path of the following object. Assume that xy denotes the object relative to the origin. At the center of the circle, use the units of time given in the description. So, and the problem describes, it's a word problem, a go-kart moves counterclockwise so motion a circle counterclockwise with constant speed the radius is 400 meters and one lap is completed in 1.6 minutes. Question. Find x of t, y of t. And t here is the time. How do we answer such a question? And here I beg you to follow with me seriously. Because this is the kind of problem that you will be having on your test. To answer such a problem, you need to understand the setup. The motion is along a circle, right? So we can draw that circle centered at the origin. Assume this is that circle. The radius is r equals 400, it says. The speed is constant. Let's say we pick a point on that circle. And this angle, we call it theta. Because the speed is constant, theta equals that speed times time, where this is the speed, angular speed. Because one lap is completed in 1.6 minutes, W will be 2 pi over 1.6. Why is that? Because one lap is a complete circle, right? Are we in agreement here? When we say one lap, it's one complete circle. For one complete circle, this angle goes all the way to 2 pi. That's why I'm getting W as the angle 2 pi divided by the time that is necessary to find to complete one lap. I'm dividing here to get W. That's it. Are we good? So I'm using this formula. And the fact that one lap, which is equivalent to 2 pi, again, one lap translates into 2 pi into an angle 2 pi. That stands for theta. And that you get W. So now if I know W And I know from the previous problem we just solved that right here, if I write this thing, and this is x, and that is y, theta here, cosine of theta is x over, cosine of theta is x over r. And that's why x is r cosine theta, and r is given 400, and theta is omega, which is 2 pi over 1.6 times t. So that's how you could find x. And sine theta is y over r. Sine of theta is this side, which is y over r. And that gives you y equals r sine theta. R is 400. And then sine and theta is 2 pi over 1.6 t. So you get the parametric equations x equal 400 cosine of 2 pi over 1.6 t, y equals 400 sine of 2 pi over 1.6 t. So this is a possible parametric equation of that motion that is described. Ask me the questions now, please, if you have. It's important to understand what happened. Any question about this? All right, if no question. All right, now we have defined these curves. We want to figure out if we want to sketch them, how do we find the slope of the tangent line, which in a regular problem is just f prime, right? That's what usually you do there. When you have y equals f of x, it asks you for the slope, you just take the derivative at the point, that's what you have. Now, when we are in parametric, x equals x of t, let's say x equals f of t and y equals g of t, then the slope is defined here, dy over dx equals dy over dt divided by dx over dt. So we need to take the derivative of y and divide by the derivative of x. This is how you would find the slope. And then plug in the point t equals t0 that is of interest. The example, let's say x equals 8 minus 3t, y equals minus 1 plus 3t. We would say dx over dt. Derivative of x with respect to t is minus 3. derivative of y with respect to t is 3. So at any point, dy over dx equals 3 over minus 3, which is minus 1. So, and this is understandable. It is a line, right? So when you have a line, the slope of a line is constant at all points. That's why it doesn't depend on t. In this case, dy over dx is -1. The slope of this line is -1, which is 3 over minus 3. So this is a line, and thus equal to its tangent, right? So the slope is the same. At all points. Questions? Is there any question? Example 2. Let's say we have x equal sine of 2t, y equals 2 sine of t, 0 less than or equal to t less than or equal to 2 pi. And the question says, find all points where the tangent line is horizontal. Question, find all points where the tangent line is horizontal. What does it mean that this tangent line is horizontal? Anyone can help with this? What's the slope of a horizontal line?
0.
0. So tangent line is horizontal means slope 0. Answer. This means slope equals 0. So you want dy over dx equals y prime over x prime, and that is y prime is 2 cosine t. That's the derivative here. It's 2 cosine 2t. You want that to be equal to 0, and you solve, and that gives you cosine 2t equals 0, and cosine 2t equals 0 gives you 2t equals pi over 2 plus k times pi, where k is an integer. This is something that you need to remember from your trig class. How to solve cosine equals 0? It's pi over 2 plus all multiples of pi. At those points, the cosine is equal to 0. And then you divide and you get t is pi over 4 plus k pi over 2. Now, given that the original problem is telling you that you need those points with t between 0 and 2 pi, then you will go to all these t's and give the ones that are between 0 and 2 pi. And that will be obtained by plugging in various values of k. If I plug in k equals 0, I get pi over 4. So that's the first. I plug in k equals 1, that's pi over 4 plus pi over 2, that's 3 pi over 4. This is still between 0 and 2 pi. Then I plug in k equal 2, I get pi plus pi over 4, that's 5 pi over 4, which is still between 0 and 2 pi. Then we plug in k equals 3, so get 3 pi over 2. So 3 times 2, that's going to be 6, and 1, 7. So we get 7 pi over 4, which is also between 0 and 2 pi. And if I add more, go to k equal 4, I get 2 pi plus pi over 4, which is a number that is larger than 2 pi, and it's going to be rejected. So there are exactly 4 points, 1, 2, 3, 4. 4 points where the slope is horizontal.
I have a question on this one.
Yes, sir.
Would you have to solve for 2 cosine t equals 0 at any point as well?
Why?
I don't know. That's my question.
Yeah, I understand. I'm just, when I ask back, it's just to see the rationale between what, behind what you're thinking. Why would
So if 2 cosine 2t came out to a number that wasn't 0, but 2 cosine t came out to 0, that slope would still be 0 at that point.
would be infinity, it won't be 0. The ratio is equal to 0 if and only if the numerator is 0.
Okay.
And technically, I actually messed up something here. So, because this is not the number I read. So I'm solving 2 cosine t equals 0, and I put it back the other one. So this answer is not for horizontal. It's not going to be that. So that's going to be infinity. Let me get this, and we just flip this guy and say vertical. Okay. Because I made a mistake here and solved this instead of that. And this is where it's infinity. And therefore the denominator is 0. And that's cosine 2t equals 0. Otherwise, everything that is written is going to be wrong. So change that horizontal to vertical. Vertical would mean that the tangent at that point is on each of the sides is going to be infinity, either plus or minus. And then that would mean that the denominator instead is 0, which is why you are not going to be able to get that. And therefore, we solve for that denominator and we get these 4 points. And that is understandable on the graph. When you look at the graph of that function, you can see the 4 points, 1, 2, 3, 4. Now for horizontal, we will have to solve this one equals 0, which will give us 2 points, pi over 2 and 3 pi over 2. So let me write that other question down. So for horizontal, tangent line, you get slope equals 0, which leads to 2 cosine t equals 0. So cosine t equals 0. So t equal pi over 2 plus k pi. And there are only 2 values, k equals 0 and k equal 1, that would work. T equal pi over 2 or t equals 3 pi over 2. So there are 2 points where the tangent line is horizontal, and there are 4 points where the tangent line is vertical. Thank you for that question, though. Any other question? So that's it for this part. And the last thing that I wanted to introduce in this lecture was to give you the polar coordinates as an example of parametric system. Where we call the ants r and theta. So we assume that we have one line that is given, and we call the direction of that line our 0 direction. We put a point O and that on that, and we pick any point in the space, draw a line from the origin to that point, and the angle that that line forms with our original line, always counted counterclockwise, is what we denote theta in the polar coordinates. The length of the line that we draw from the origin to the point M is what we call the R. That's the length of the arc from the origin to the point, and theta is the angle between the 0 direction and the arrow that we draw from the origin to the given point. So we say R theta are called polar coordinates of the point M, which coordinates x, y, and these x, y is what we call the Cartesian coordinates. So you got Cartesian coordinates and you got parametric coordinates. And there is a relationship between the two. How to move from the polar to the parametric, and how to move from polar to Cartesian, and how to move from the Cartesian to the polar coordinates. So that's what I'm going to give you right now. So here, if I complete this figure by drawing something down here, what I will hit here will ultimately be what we call x in Cartesian coordinates. And if I complete here the angle pi over 2, then this side here is what we call y in Cartesian coordinates. Just as I did in a problem earlier, x is r cosine theta and y is r sine theta. So if I have the polar coordinates, I can always find the Cartesian coordinates by plugging them in here to switch. Or I can go find the polar coordinates. R is square root of x squared plus y squared. If I know x and y, then I can find the polar coordinates. First, getting r as square root of x squared plus y squared. You can see that here on this graph, this is a rectangle. This is a triangle with a right hand angle right here. So the size of r is square root of x squared plus y squared. Or you can algebraically show that here. You see x squared plus y squared is r squared, because cosine squared plus sine squared is 1. And so you take square root, you get r equals square root of x squared plus y squared. And then you can find theta through cosine and sine. Cosine theta is x over r and sine theta is y over r. So if I have x and y, I find r, and I plug in here to find cosine and sine theta. Once I have cosine and sine of theta, the angle theta is unique. Of course, this is done when r is not 0. Right? When r is 0, any angle is okay. Right? So, example, let's say M has coordinates 2, 2, for example. This is in X. Fine. What are the polar coordinates? Then you would say R equals square root of x squared plus y squared. That's square root of 4 plus 4. That's 2 square root of 2. Cosine theta is x over r. That's 2 over 2 square root of 2, which is 1 over square root of 2. Sine theta is y over r, which is 2 over 2 root 2, which is 1 over root 2. And these two show you that theta is pi over 4. There is no other angle that has cosine 1 over root 2 and 1 over root 2 for sine. The only angle is pi over 2. So polar coordinates are 2 root 2 pi over 4. And so in the opposite direction, if you have coordinates for 2 pi over 3 in polar, what are the Cartesian coordinates? And the way you find that is by using the formula x equal r cosine theta, y equals r sine theta, leading to x equal r is 4, theta is 2 pi over 3. So cosine of 2 pi over 3, that's negative. That's the opposite of cosine of pi over 3. And the cosine of pi over 3 is 1/2, so that's minus 4. 1/2, so that's minus 2. And here sine of 2 pi over 3 is positive, so that's 4. And it's equal to sine of pi over 3. And the sine of pi over 3 is root 3 over 2. And so that is 2 root 3. So Cartesian coordinates here -2, 2 root 3. So this point in polar coordinates corresponds to these coefficients in Cartesian coordinates. Is there any question? All right, that's it for me today. Let's see you next time.
Thank you, Dr. Longwell.
Yes, sir.
Thank you.
Thank you for coming.